right. First, what is chemical equilibrium? First, equilibrium. What is equilibrium? For any chemical reaction, initially we have reactants. Initially we have reactants only, right? Sometimes reactants, only one reactant is present. That reactant is converted into product. A single reactant gives a single product. Okay, so reactants gives products. Sometimes more than one reactants are involved in the reaction. Those gives more single or more than one products are given. That is depending upon the nature or using reactants, nature of the reaction and using reactants. So in any chemical reactions, reactants and products are present. If the reactants are involved in the reaction, those gives the products. Simple example, for preparing an egg curry, we use number of ingredients like eggs, oil, onion, tomato, chili. So these are all used as reactants. But those gives only one product, that is egg curry. So reactants gives product. Reactants gives product. Such type of reactions are called irreversible reactions. I will explain later this one also. So only reactants gives products. After some time, only products are present. There is no reactants. There is no reactants. If you use more number for the preparation of the egg curry, sometimes reactants are left. Excess reactants are used. Then excess amount is means, for example, only 3 eggs are used for the preparation of egg curry, but available 10 eggs means 7 eggs are left. So after complete the reaction, reactants are available. Okay. So in most of the reactions, in some reactions, total reaction completed. Completed means there is no continuation. End of the reaction we observe. End of the reaction we observe. So in most of the cases, only products are present. There is no reactants. Such type of reactions are called irreversible reactions. Irreversible reactions means reactants gives products. And also we use one word. This reaction is called reactants gives products. This reaction is called simply forward reaction. What is this reaction? Forward reaction. Are you understand, Anna? Forward reaction. Sometimes product is converted to reactants. This is called backward reaction. Backward reaction. Right? So if only reactant is converted to product, this reaction is called irreversible reaction. Both are simultaneously occurred, or both are continuously occurred. Such type of reactions are called equilibrium reactions or reversible reactions. Such reactions are represented like this. A gives rise to B. This type of arrow marks indicates equilibrium reactions. In equilibrium reactions, both forward and backward reactions, are takes place. Means this reaction is not completed. This reaction is not completed. Not completed means A is converted to B, at the same time B is converted to A. Means there is no chance for the end of the reaction. Such type of reactions are called equilibrium reactions. Okay. Equilibrium reactions are observed in both physical changes and also in chemical changes. First one, equilibrium in physical changes. Equilibrium in physical changes or physical equilibrium. Physical equilibrium. Generally, these physical changes observed in equilibrium observed in the physical changes are solid is converted to liquid. This is one type. liquid is converted to gas, means solid is converted to liquid. At the same time, liquid is converted to solid. In this reaction, liquid is converted to gas, gas is converted to liquid. Third one, solid is converted to gas and gas is converted to solid. Total 3 types of physical changes observed in the equilibrium. First one, solid liquid equilibrium. Solid liquid equilibrium. In solid liquid equilibrium, what is the best example for this one is water. Means ice is converted to water. This is also written like this: H2O in solid state and H2O in liquid state. Where they are observed, H2O in solid state, ice is converted to liquid. It is simply, what is this one? What is the process? Melting point. Melting point, that is called melting point. Melting point. Liquid is converted to solid. Water liquid is converted to water solid. Water solid means ice. It is called freezing point. Freezing point. So here, melting and freezing both are in equilibrium. Both are in equilibrium. So first I will explain about melting point. What is the melting point? Melting point means at a particular temperature, solid and liquid. Actually, we are taking solid material. That solid material is at a particular temperature maintains equilibrium. Means that solid is completely converted into liquid, not completely converted. At such a particular temperature, the solid is and liquid both are at equilibrium. If above that temperature, solid is converted to liquid. Solid is converted to liquid. And reverse one is freezing point. Okay. So this is about solid liquid equilibrium. Best example, ice and water. Second one, liquid gas equilibrium. Liquid gas equilibrium. Liquid gas equilibrium means, what is the best example? Water in liquid state. Equilibrium is water vapor, means water in gaseous state. These two are in equilibrium. Equilibrium means liquid means water. Water is converted to gas means what is the process? Evaporation. Okay. Water vapor is converted to liquid means condensation. Now I will give a perfect clarity about this one. That is rate of evaporation is equal to the rate of condensation. At equilibrium, rate of evaporation is equal to the rate of condensation. Sir, what is rate? Rate means, for example, take reactant. In 1 second time, how much reactant is converted to product? For reverse one also, same definition. For rate, reverse one means in 1 second time, how much product is converted to reactant? That is called rate. Means calculation in 1 second time. In 1 second time, rate of evaporation means in 1 second time, how many liquid water molecules are converted to gas? Rate of condensation means in 1 second time, how many gaseous water molecules are converted to liquid? At equilibrium, these two are same. Means how many liquid particles are converted to gas is equal to the how many gaseous particles are converted to liquid. Means that's why these two are continuous. Liquid to gas, gas to liquid. Continuous. That's why the reaction is not completed. So they attain equilibrium. Similarly, third one is, what is the third one? Very easy. Third one, solid to gas equilibrium. solid to gas equilibrium. Solid to gas equilibrium means we know that very well about this one. Camphor. Camphor in Telugu Katpur. Camphor present in solid state. It is converted to, this is solid state. This is converted to camphor gaseous state. Camphor gaseous state. In this one, rate of sublimation means solid is converted to gas means that is rate of sublimation. What is sublimation? Sublimation means solid material is directly converted to gas. Rate of sublimation is equal to the, here also rate of condensation. So condensation means gas to solid or gas to liquid. Condensation. Okay, Nana? So both are same. Some more example for this one, that is iodine. I2 solid to I2 gas. This is also one more best example. Third one, ammonium chloride. Ammonium chloride. NH4Cl. Ammonium chloride present in solid state. We can be converted into ammonium chloride in gaseous state. This is about equilibrium in physical changes. Next topic, equilibrium in solutions. First, what is solution? Solution means solvent plus solute. Solvent plus solute equal to solution. Okay, Nana? For example, solvent means water. Add salt, NaCl, for example. NaCl, salt, table salt or common salt. Okay, they give a salt solution. A salt solution. But we know that three types of solutions. Unsaturated solution, unsaturated solution, saturated solution, supersaturated solution, supersaturated solution. What are the difference between these three solutions? Unsaturated solution means if you take a glass of water, add just very small amount of NaCl. Actually, it is not sufficient. It is not sufficient. So such type of solution is called unsaturated solution. So simply another example for this one. Every day we take a meals. For example, in morning in breakfast time every day I take 5 idlis per day in morning breakfast time. So one day I took only 2 idlis, means that is not sufficient to my stomach. Such type of solution is called unsaturated solution. If I take exactly 5 idlis, that is called saturated solution. Saturated solution means, for example, water is a solvent. If for example glass of water takes 1 spoon of required 1 spoon of salt, big spoon, 1 spoon of salt. If you add that exact 1 big spoon of salt, it is sufficient for that water, that 1 glass of water. If you add the extra amount of salt, that salt is not dissolved in water and that salt is settled at the bottom of the glass. So if extra amount is added, that is settled at the bottom of the glass. Such type of solutions are called supersaturated solutions. Supersaturated solutions. So simply, for equilibrium in solutions, first write what is the saturated solution. What is the saturated solution? This is shortcut for solution. Saturated solution. What is the definition? A solution in which no more solute can be dissolved is called a saturated solution. That is the definition. So in saturated solutions, solute and solution. Okay, sorry. Solute. So solute initially solute is present in solid state. For example, if you take NaCl, it is present in solid state. If it is added in the solvent, it forms a solution. Then it is the solution. These two in the equilibrium means that solute and solvent both are maintains equilibrium. So this is the equilibrium in solutions. Equilibrium in solutions. One more example for this one. Carbon dioxide in sodas. Carbon dioxide gas is used. This gas is, if dissolved in the water, it forms a solution. Here, these two are also in the equilibrium because they maintain saturated solution. Simply, in saturated solutions, solute and solution both are maintained equilibrium. Okay, Nana? Next one, equilibrium in chemical changes. Chemical changes means we have to take the chemical compounds. That chemical compound is converted into another chemical compound. So those are not directly physical changes. Physical changes means just change the states. State means solid is converted to liquid, or liquid is converted to gas, gas is converted to liquid, liquid is converted to solid, or gas is converted to solid. That is the physical changes. But in chemical changes, directly one compound is converted into another compound. Or if you mix the two compounds, the two compounds gives one compound. Or two compounds gives the two or three more compounds. Okay, such type of reactions are called chemical changes. Okay. Before going to the explanation of the chemical changes, actually equilibrium chemical changes, first one is the important one, irreversible reactions. Irreversible reactions. So actually irreversible reactions are not equilibrium reactions because there is directly A gives rise to B or A plus B gives rise to C plus D. C plus D. This type of reactions are occurred in open vessel. Open vessel means there is no closing. The reaction takes place in open tube or in open test tube. There is no closing. Okay, sometimes some reactions occur in closed vessel also because there is no changes. If two are reacted to give a new product, that new product is there is no chance to convert it into reactants. Okay, so irreversible reactions occur both in open, closed vessels. Occur both in open and closed vessels. Now, best examples explanation now. Examples for irreversible reactions. Irreversible reactions means reactant is converted into product. There is no chance for product is converted to reactants. Means only forward reaction takes place. Examples. First one, thermal decomposition reactions. Decompose means divide. Okay. Thermal means heat. Means if you apply heat, okay, if you heat that substance, it is decomposed into two or more compounds. So here KClO3 is heated in the presence of MnO. It is acts as a catalyst. That is not useful here. KClO3 is converted to KCl plus O2. Decomposed to KCl plus O2. Here, ammonium nitrate is decomposed to N2 plus water. In this reaction, sodium carbonate is decomposed to sodium oxide and CO2. These are all irreversible reactions. Simply, thermal decomposition reactions are irreversible reactions. Second one, PPT means precipitation. Precipitation reactions. Precipitation reactions means this is one test tube. Already one solution is present in this one. If you have any other solute in this solvent, they form an insoluble solid material. Insoluble solid material. And small particles are we observed. Insoluble solid small particles we observed in the solution. those are settled at the bottom of the solution. Such type of smaller particles are called precipitated molecules. Okay, precipitated molecules. Are you understand? Those are not soluble in the solution. Those are settled at the bottom of the solution. Okay, that's such type of reactions are precipitation reactions. Actually, BaCl2 and Na2SO4, these two are, if you involved in the reaction, actually BaCl2 is white in color only, but there is no precipitation. But if BaCl2 is reacts with Na2SO4, this BaCl2 is converted to BaSO4. Means this Ba and this SO4 combine together to form BaSO4 and form a white precipitate. BaSO4 is a white precipitate, means white type of small pieces we observed, those are settled at the bottom of the test tube. Okay, and NaCl is formed, but NaCl is soluble, means present in the solution, but it is not settled at the bottom of the test tube. Another example, AgNO3. Actually, AgNO3 is colorless. Colorless means like water. But if water is present in the ice form, we observe white color, but that is not a white color. But water molecules, all the water molecules are comes very close. That's why the ice is present in white in color, but that is not a white color. Similarly, AgNO3 also. AgNO3 is also colorless, but sometimes it looks like white in color. If AgNO3 is reacts with NaCl, it gives AgCl. Means this Ag is reacts with this chlorine, it gives AgCl. It is also forms white precipitate and also give NaNO3. So remember this precipitation formulas and colors. Next one, lead nitrate. Lead nitrate, actually white in color. If lead nitrate is reacts with potassium iodide, it gives PbIT. Lead iodide is formed. Lead iodide is yellow precipitate. See which color? Yellow color. We observed yellow color. Okay. These are all precipitation reactions. Thermal decomposition reactions, precipitation reactions, these two are irreversible reactions. Other examples, third model in irreversible reactions. Neutralization reactions. Neutralization. If you take acid and base, for example, in classroom, 10 members boys, 10 members girls. Boys means acids, girls means bases. 10 neutralized. 15 members boys, 10 members girls. Acidic in nature because more number of acids are present. It is not in neutralization. Are you understand? So we observe neutralization reactions in acid-base reactions. Acid plus base gives rise to salt plus water. These are neutralization reactions. Acid HCl, base NaOH gives rise to salt NaCl plus H2O. Very simple. From NaOH it gives Na, from HCl it gives Cl. This Na and Cl combine together to form NaCl, and remaining this H and OH combine together to give H2O. Okay, Nana? These are neutralization reactions. Next one. Next examples are reversible reactions, redox reactions and combustion reactions. Redox reactions means RED means reduction, OX means oxidation. So either oxidation or reduction reactions are simply called redox reactions. This is the redox reaction. SnCl reacts with FeCl3, gives SnCl4 and FeCl. In SnCl2, Sn oxidation state is +2. If it is reacts with FeCl3, it is converted to SnCl4. Here, Sn oxidation state is +4. +2 is converted to +4. +2 means it is already lost 2 electrons. +4 means 2 more extra electrons are lost. So loss of 2 electrons. So it is a oxidation reaction. Similarly, FeCl3, Fe oxidation state is +3. In FeCl2, Fe oxidation state is +2. +3 is converted to +2 means +3 already lost 3 electrons, but here lost only 2 electrons. Means converted to FeCl3 to FeCl2 means gaining 1 electron. Okay, so it is a redox reaction. sorry, it is a reduction reaction, reduction. So SnCl2 is converted to SnCl4 is oxidation, FeCl3 is converted to FeCl2 is reduction. Overall redox reaction. Next one, combustion reactions. Combustion in manta pettam, dahanam. Okay, so for combustion process, what is the required one? Oxygen is required. So if reacts with oxygens, those are called the combustion reactions, directly heated with the presence of oxygen. So Mg plus O2, MgO, ethyl alcohol, this is ethyl alcohol, CTH5OH, ethyl alcohol reacts with oxygen, is converted to CO2. Wait. I think oxygens 3, 4, CO 2, 5, 2O2. Right. Balancing reaction. Okay. These are the irreversible reactions. Next one, reversible reactions. These are the chemical equilibrium reactions. Reversible reactions means this indicates equilibrium, or reversible means forward, and this is backward reaction. This is also represents reversible reactions. Okay, Nana? But what is the main point? Reversible reactions always carried out in closed vessel. Closed vessel. Why? In closed vessel means, if you carried out in closed vessel, if you carried out in open vessel, there is chance for evaporation of the products. If any gaseous product is obtained, the gaseous product is evaporated. There is chance for evaporation. That's why if you close the container or the vessel, there is no chance for the evaporation of the gaseous reactants or gaseous products. That is the reason. Now examples. First one, Haber process. In Haber process, ammonia is prepared, and hence this ammonia. How it is prepared? 1 mole of N2. 1 mole means there is nothing. There is no number means 1 is there. 1 mole of N2 is reacts with 3 moles of H2. It gives 2 moles of ammonia. And a reverse reaction is also possible. So ammonia preparation in Haber process is a reversible reaction. And second one, contact process. Actually, in contact process, sulfuric acid H2SO4 is prepared. But in the H2SO4 preparation, a sulfur dioxide is required. Sulfur dioxide means very simple. If SO3 reacts with water, it gives H2SO4. This is the final preparation. So SO3, sulfur dioxide, is one of the required material for the preparation of sulfuric acid. So this sulfur dioxide. This sulfur dioxide is prepared by using sulfur dioxide and oxygen. 2 moles of sulfur dioxide is reacts with 1 mole of oxygen. It gives 2 moles of sulfur dioxide. It is also a reversible reaction. Forward and backward reactions both are takes place. Next, third one, calcium carbonate. Actually, this is present in solid state. This solid, if you heat this one, it is dissociated to calcium oxide, solid, and gaseous carbon dioxide. And the reverse one is also takes place. This calcium oxide again reacts with carbon dioxide. It is converted to calcium carbonate. It is a gas. That's why the reaction must be carried out in closed vessel. Otherwise, if it is evaporated, only CaO is present in that vessel. There is no chance for the conversion into CaCO3. Next, when iron is reacts with the steam. This water means steam water. It is converted to Fe3O4. Corrode means rusting, and gives hydrogen gas and also hydrogen. Next, see this one. CH3COOH. This is COOH means carboxylic acid. So this is acetic acid. Acetic acid is reacts with alcohol, ethyl alcohol. It is ethyl alcohol. If acid is reacts with alcohol, it gives ester. Ester means this H, this OH, both are combined together to form H2O. Another remaining terms CH3COO C2H5 means it looks like COOR model, means ester. This is called esterification. Esterification. Are you understand? When carboxylic acid reacts with alcohol, it gives ester. It is called esterification. Okay, next one. PCl5, phosphorus pentachloride is dissociated into PCl, phosphorus trichloride and chlorine. It is also reversible reaction. Next, 2HI, H2 plus I2. But important one is, it is a color change reaction. It is a color change reaction because HI is colorless gas. H2 is also colorless gas, but iodine is a violet gas. Violet gas. So it is a reversible reaction. Now come to the next example. N2O4, nitrogen oxide. N2O4, tetraoxide. It is a colorless gas. It is converted to nitrogen dioxide, and nitrogen dioxide is also a reddish brown colored gas. It is also color change reversible reaction. Very important. Okay, next one. N2 plus O2 gives rise to 2NO. It is also reversible reaction. Very easy. Ammonium sulfide, hydrogen ammonia, hydrogen sulfide gives ammonia and H2S. Okay, this is also reversible reaction. These are all examples for reversible reactions. These reversible reactions are also classified into two types. Write down. Now write the point. Reversible reactions are further classified into two types. First one, homogeneous. Homogeneous reactions. No need to write chemical or equilibrium. Write homogeneous reactions. In homogeneous reactions, for example, if you take H2 plus I2 gives rise to 2HI. This is gas, this is gas, this is also gas. Means in homogeneous equilibrium reactions, all the reactants and products present in the same phase. Present in same phase. Are you understand? Both reactants and products are present in the same phase. Another example. CH3COOH, acetic acid, C2H5OH, ethyl alcohol. It gives CH3COO, C2H5, ethyl acetate, ester plus water. Here in this reaction also, this is liquid, 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 liquid. All the reactants and products are present in the same phase. Such type of reactions are called homogeneous reactions. Second one, heterogeneous reactions. Heterogeneous reactions. Very simple. Heterogeneous reactions means present in different phase. Present in different phase. Okay, Nana? Different phase means MgCO3 gives rise to MgO plus CO2. Magnesium carbonate present in solid state. Magnesium oxide solid state. But CO2 is gaseous state. Means all the reactants and products are not present in the same phase. Two are solid state, but one is in gaseous state. One more example for this one. See the second example. Sodium peroxide, solid state. Water, liquid state. Sodium hydroxide, liquid state. Oxygen, gaseous state. Means one solid state, two liquid states, and one gaseous state. Means not all are present in the same phase. That's why these two are best examples for the heterogeneous reactions. Today class is completed. Thank you very much.